Welcome to my YouTube channel. So today we are going to do the part 11 of the topic trigonometry. So in this one we are going to see how to prove the trigonometric identities. So now let us start here. So here it's given this is the 10 square x plus 1 is equal to sec square x. Let us keep the LHS as it is over here. So now 10 square x is sine square x plus cos square x plus this 1 we can write as cos square x by cos square x. Why? Because see the denominator is here cos square x and we want this later on we want this as sec square x. So here it becomes easier. Now let us see how. So now we got the denominator both places cos square x and this will be added, that will be sine square x plus cos square x, and you know the first identity sine square x plus cos square x, that is 1, and this is cos square x. So now let us keep as it is first, and now let us see the RHS. RHS is sec square x and that sec square x is nothing but 1 by cos square x. So now you can see the LHS and this is the RHS. So LHS is equal to RHS. So what we can see, 10 square x plus 1 is equal to sec square x. Now in the next problem it said that sin square x minus 1 minus cos x is 1 plus cos x. So this is what is LHS. So now what we can do here, sin square x we can write as 1 minus cos square x. Sin square x plus cos square x is 1. So what we can write here, sin square x is 1 minus cos square x. So for this one we can write here 1 minus cos square x and this we'll write as it is. So now see what is this here, a square minus b square. So now this we can write here a square minus b square is a minus b and a plus b. So now because here it's 1 but we can write here 1 square as well. So that is we can use this formula. So a minus b and a plus b means 1, this a is 1 and b is cos x. So you can write here 1 minus cos x and 1 plus cos x. This is important and the denominator the same. So what we can do here, we can cut this and this one. So remains is 1 plus cos x, then that is RHS. So what we can see now, that is the right hand side is the same. So we can say LHS is equal to RHS. So because of that, this is the same thing. We are going to write it over here. Therefore, this is equal to this one. Now the next one, 1 minus cos square x is equal to 10x cos x sin x. So left hand side as it is. So you know 1 minus cos x cos square x is equal to sin square x, the first identity. Now let us take this RHS. So 10x we can write sin x by cos x. This cos x as it is, sin x as it is. This and this gets cancelled. So what we can write here, sin square x. So what we can write here, this also is sin square x and this also is sin square x. So LHS is equal to RHS. Therefore 1 minus cos square x is equal to 10x cos x sin x. Now the next one, left hand side as it is. So what we can write here, this will be as it is, this will be as it is. For this cot square x, what we can write here, 10 is sin by cos, cot will be the reciprocal of that, that will be cos by sin, that will be here this square, so we'll write here cos square x by sin square x. This will be as it is. Now see, we'll take the LCM over here, sin square x is the LCM, so we'll put here sin square x and this is again sin square x. So what will we write here, sin square x plus cos square x and this will be sin square x. So now this is actually multiplication, so this and this gets cut. So what remains is sin square x plus cos square x and which is 1. So which is RHS. So we can say left hand side is LHS is equal to RHS. So this is equal to this one. So this you have to write it because it is, you have to prove it. Now here, this is the left hand side. So first now look at here, sec x will be 1 by cos x and this the denominator as it is. Again the cosec is 1 by sin x and the denominator as it is. Now this is the numerator and this is the denominator. So this is actually, there is a 1 over here. The denominator has 1. So what happens here, the numerator remains as it is, but the denominator gets flip over. So that will be 1 by sin x. Hope this is clear. Then this plus as it is over here. Again the numerator will be as it is and the denominator has got 1. So this is going to get flip over. So that is going to be 1 by cos x. So now what we can write here, 1 by cos x sin x. This is what is here. Again we can write here 1 by sin x cos x. So this is over here. So now we want here 2 by sin x cos x. So we want the start is sin x cos x. So this we can rearrange because you know this is multiplication. Either you write 3 into 4 or 4 into 3. Both is going to be the same. So we can write here sin x cos x for our convenience. This will be 1 plus 1, that is going to be 2, because here is also sin x cos x and here also sin x cos x. That means that is the LCM, and which is, we can say that is the RHS. That is what is given over here. So we can write this one is proved. So now look at here, this is the LHS, so we'll write here the same. Now what we can do here, this LCM is here 1 plus cos x and here is 1 minus cos x. So we can put here extra 1 minus cos x, multiply by 1 minus cos x. So this is extra, means here also we are going to 1 minus cos x. And here what we need 1 plus cos x. And this is going to be 1 plus cos x. So what will be here 1 minus cos x? And so the LCM is 1 plus cos x and 1 minus cos x. So what is that going to be? 1 minus cos x plus 1 plus cos x is over here. So what we can do, this and this we can cancel out. So 1 plus 1 is going to be 2. And this is a plus b and this is a minus b. So a plus b and a minus b, a plus b and a minus b. So what is that going to be? That is a square minus b square. So that it will be a square, means this is going to be 1 square minus b square. B square is going to be cos square x. Hope you got this one. So now what we can write here, we can write this 2 as it is. 1 minus cos square x, that is going to be sin square x. So you know the first identity, that sin square x plus cos square is equal to 1. So 1 minus cos square x is sin square x. So now what we have to prove, that 2, we on the right hand side we need 2 cosec square x. So what we can do, we can split this one. 2 we'll write it on the one side. So what remains is 1 by sin square x. So 2 will be as it is, 1 by sin square x, that is cosec square x, and that is what we have to prove. So we can just, I forgot to write over here, that will be LHS equal to RHS. So you can write this one, and so you will write there, and then you will write this one. So this is proved. So you write this sentence again, and then you can say that is proved. So now look at here again here. This is the LHS. So what we can do here for this one, this is a square minus b square. So you know a square minus b square again, that will be a minus b and a plus b. So what is a is here cos x, b is sin x. So you can write a minus b and this is a plus b. Hope you got this one. And from this one, this is the first term and this is the second term, because there is a plus the separator over here. So from this one, what you can see, cos x is common. So you write cos x out of the bracket. And here now cos square x means you will write here cos x inside, and sin x cos x means, hope you got this one. This cos x is for both of them. So now what you can do, this is multiplication. So this and this gets cancelled. So what remains, this is here. So now you can separate it, cos x by this one, and this will be like this. So cos x by cos x minus sin x by cos x. So cos x by cos x will be 1 and sin x by cos x, that is 10. So that is what they are asked. That is the RHS. So this is RHS. So LHS is RHS, and this is proved. Now here again we'll write this one same. Chord means cos by sine. This will be as it is, this will be as it is. So now what we can do here, we can see the LCM, we can check. Here you need extra 1 plus cos x. So this is extra, means here also you need 1 plus cos x. So here will be what? Sin x. And here also will be sin x. So what will be the 1 plus cos x, and this is cos x plus sin x into this sin x. So what remains is sin x and 1 plus cos x. So what we can do now, see here, this is the first term and this is the second term. So we can put this into this, that is cos x, and this into this is going to be cosec square x, and this is going to be sin square x, and this will be as it is. So now what we can do here, we can write here cosec square x plus sin square x, that is going to be 1, and this cos x here. So this will be as it is over here. So now what we can write here, for this one we can write here 1 plus cos x, and again this will be the same. So what happens here, this and this gets cancelled. So remains is 1 by sin x, and which is 1 by sin is cosec x. So that is LHS is equal to RHS, and then this is proved. Now let us see here, that is, this is the left hand side. So what we can write here, we can write this same. For this one, we can write sine by cos, and because this is cube, we can also write here cube. So now what we can do when this is multiplication. So when we compare this, because this is in the numerator, this is in the denominator. So from this one in the denominator, if we cancel out, means there remains is only cos square x. This is gone. So now this is as it is in the numerator. So now what you can do, this you will keep separately first, then we will take the RHS. This is the RHS. This will be as it is. And for this 10 square x, we can write here sine square x by cos square x. So now what happens? Here we can see that is sine cube x, because this is 1 and this is 2. And this is the denominator cos square x. So when we compare this and this, the LHS and RHS both are same. So we can say LHS is RHS. So this is proved. So by this one, we have completed today's work. Do like and subscribe to this channel so that you get the notification of the other parts. Thank you.